Okay, today we are going to talk about strategies that we can use to multiply all combinations of factors, including whole numbers, fractions, and mixed numbers. So I'm gonna walk through page 33 in the textbook real quick. And so we're gonna model different multiplication situations today. So in our previous lesson, we talked about using the word of in multiplication statements with whole numbers. For example, 2 groups of 12 would be the same thing as 2 times 12, which would be 24. In our first problem, we wrote number sentences such as 3/4 of a half would equal 3/8. Mathematicians use multiplication to rewrite number sentences involving fractions. When we multiply a fraction by a fraction, we are finding part of a part. So 3/4 times a half would be 3/8. What strategy helps you multiply two fractions that are each less than 1? Well, what strategy helps? The fact that we can look at things like 3 times 1 equals 3, and 4 times 2 equals 8. So one way of looking at this is that we're simply multiplying the numerators together to get our numerator of our product, and we are multiplying the denominators together to get the denominator of our product. So we can also model multiplication situations that involve mixed numbers. For example, 2.5 groups of 12 would equal 2 groups of 12 and a half a group of 12. So 2 times 12 plus a half times 12. This kind of looks like the distributive property expanded form, doesn't it? This would be the same thing as saying 12 times 2 plus a half. And so when I solve this, I get 2 times 12 is 24, and a half times 12 is 6, because half of 12 is 6. And then I get 24 plus 6 is 30. So over here in my egg crates, if I had a dozen here and a dozen here, and then only half a dozen, so 12 plus 6 is 30. All right, so let's go on and try to apply these to some problems. It says, estimate an answer, draw a model or diagram to find the exact answer, and then write a number sentence. So I'm going to walk through question A1 and do this. So on my paper, I'm going to write A1, and it says, a recipe calls for 2/3 of a 16-ounce bag of chocolate chips. How many ounces are needed? Well, the first thing would be to draw or estimate the answer. So I know that I'm trying to figure out what 2/3 of 16 is. Well, since I have one factor that is less than 1 and one that is greater than 1, I know that my answer should be smaller than 16, because if I had 1 times 16, my answer would be 16. But since 2/3 is less than 1, then less than 1 times 16 would give me an answer less than 16. Okay, so I'm going to use that. So my answer should be somewhere around, I probably think 12, maybe 13, 12 or 13 ounces. Okay, so now what we're going to do is we are going to draw a model or diagram to find the exact answer. So what I'm going to do is I am going to draw a very long rectangle, and I'm going to divide this into 16 parts. So in half and half. So there's 4, and now each fourth gets cut in 4. So I have 1/4. There's 4. There's 8, 12, and 16. So I'm going to look at this as an individual. There are 16 different rectangles here. And now I'm going to go the other way and show 2/3. Okay, so here is, and then 2/3 would be this would be 1/3 of all of my 16, and this would be all of my 16. Okay, so now what I'm going to do is I'm going to count up how many thirds I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. So I have 32 thirds, and now I need to simplify this. So how many times can 3 go into 32? Well, I know that 3 times 10 equals 30, so I could get 10 as my whole number, and then I'd have 2 thirds remaining. Okay, so 32 thirds would be the same thing as the mixed number of 10 and 2/3. So I would get 10 and 2/3 ounces. Okay, so my estimation was just a little bit off. All right, so my number sentence then for that part would be that 2/3 times 16 equals 32 thirds, or 10 and 2/3. All right, so let's see. And I know that a whole number is really a fraction over 1. Okay, so if I write it like this, if I turn both numbers into a fraction, does the method that we talked about earlier about numerator times numerator equals numerator, denominator times the denominator equals our product denominator, does that still apply? Well, let's take a look. Numerator times numerator equals 32. Denominator times denominator equals 3. Okay, and that gave me 32 thirds, or 10 thirds, but then I also modeled with a picture to prove my answer. All right, so take a few minutes. If you need to, go back and rewatch any part of this video. What you need to do before coming to class tomorrow is you need to try A2. Thank you.